Hey guys, today we're going to introduce forces. So there are two types of forces that we're going to be looking at. The first type of force is a contact force, which is a force that occurs through touch. Two things actually have to be touching for these forces to happen. The other type is a field force, which are forces that occur without touching. While there are multiple of these, we're only going to focus on one. So here are the types of contact forces. I'm going to go through and explain each one and then show you the symbol that I use in order to indicate these in class. The first one is an applied force, and that is the name that we give any force that's a push or a pull on an object. And that is a capital F with a subscript APP. The next one is a frictional force, and that's a force that opposes motion, so something that goes against motion, and that is capital F, lowercase subscript f. Now, frictional force, you have to remember, always goes the opposite direction of whatever the motion is. So if we include it, if you are moving to the right, your frictional force is always going to be towards the left. Air resistance, which is a frictional force that is specific to air molecules, and your symbol for that is FAIR. Most of the time we do ignore these unless I use keywords such as an object is floating to the ground at a constant velocity. Otherwise, we don't use air resistance, especially when we deal with cars on the ground, because it just adds in one extra step that we would have to do. So F-air, or air resistance, is only used with objects that are in free fall in terms of this class. The normal force, which pushes up on an object from below, it is perpendicular to the surface and is sometimes called a support force. That is capital F, subscript capital N. And I'm going to make a little drawing over here. If you are on a flat surface, and this is the object sitting down, the normal force is always perpendicular to the surface. So here the Fn goes directly up. If you have an object that is on an inclined plane, which is what we're going to look at in the next unit, if this is the object sitting, your normal force is perpendicular to the surface. So since the surface is at an angle, your Fn goes up in this direction. Okay, so keep in mind perpendicular to the surface has to be held true for normal forces. Then we have tensional force, which is a force exerted by rope, string, or thin wire, which is F with a subscript capital T. And then we have a spring force, which is an F with a subscript S. Okay, so here are the forces that we're going to be using in our free body diagrams in all of our problems. I just want you to have one location where you can find them all easily. Now we have one type of field force that we're going to be looking at, and that's the force due to weight. This is also called the force due to gravity. It always pulls directly downwards on an object, and the symbol is F lowercase g. So again, that same drawing from above, force due to gravity always pulls directly downwards. So if we have this picture again of the object on an incline, we are going to put that arrow directly downwards towards the center of the earth. Okay, so weight is also the force due to gravity directly downwards. So what we're going to do with these first is do free body diagrams. These are used to show the number of forces acting on an object along with their relative size and direction. So in order to draw a free body diagram, I want you to draw a dot to represent the object. That just simplifies things even more for us. I don't want to have to draw a car if we're talking about a car traveling down the road. So just a dot will do just fine. If you don't like the idea of a dot, you can also use a box like we did on the last slide. That gives you an idea of direction and how it's sitting on certain surfaces. Then you have to draw an arrow for each force that is present. But specifically, there are three things I want you to keep in mind. Each arrow begins on the dot and is drawn outward. So you are starting from the center and working your way out. The size of the arrow should be equal to the size of the force, so bigger forces have bigger arrows. And the direction of the arrow is the same as the direction of the force. Then we're just going to label each of the arrows using the symbols from the previous slides. So here's our first free body diagram. I want you to draw a free body diagram for a book sitting at rest on a desk. So you should have two forces acting on that book. Your first force is force due to gravity, and force due to gravity always goes directly downwards. And your second force is the normal force, and that is always going perpendicular to the surface. Okay? Since it is sitting on a desk and it is motionless, you can do a dash on both of these lines to indicate that those two forces are the same size. So that's just an extra math indicator telling me that they are the same size. We're going to do another one. I want to draw a free body diagram of a book being pushed to the right, accelerating. So the book is still sitting on the desk, but it's being pushed to the right and is accelerating. So again, you have to have gravity going down. You have to have your normal force going up. I'm going to indicate that those two lines are the same length because it looks like one might be slightly longer than the other. It is being pushed to the right and it is accelerating. So if we draw an arrow to the right, that is our applied force. And since it is sitting on a desk and not a frictionless surface, we're going to draw an arrow to the left. But the important aspect is since it is accelerating, these two arrows should not be the same size. The F applied should be larger. So when we get into class tomorrow, we're going to practice drawing free body diagrams given certain scenarios. If it is a constant motion, you're going to have the same length of arrows. If it is accelerating, you're going to have arrows that are different lengths. If it is something that is like a bucket being pulled up a well, you will have a tensional force because it is being pulled by a rope. Okay, so I'll see you tomorrow so we can practice.